Shielding effect. Assalamu alaikum, my dear students. How are you? Today my topic is shielding effect. This exists in periodic table because there are electrons in different shells. As the number of shells are increases, the shielding effect increases. What is shielding effect? Nucleus is positively charged, electrons are negatively charged, so there is attraction. Nucleus attract electrons, pulls electron. But if the shells are increased, shell are more, then this attraction gradually weakens. And this happens in along the down the group vertical lines like hydrogen, lithium, sodium, potassium. In these, one shell, two shell, three shell, four shell respectively. So as the number of shells increases, this attraction of nucleus toward the electrons decreases. Means shielding effect down the group increases. But along the period, same number of shells. For example, in second period, when we discuss second period, second horizontal line, that is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. In all these elements, they have two shells only. Like lithium, 2 and 1 electrons are in lithium, that is two shells. Beryllium, two shells. In all the elements of second period have two shells. So there is no change in shielding effect, that is they have fixed, they have unchanged shielding effect. I am reading this as electrons orbitals are added. The electrons between a nucleus, between a valence electron and the nucleus repel the electron. The shells have electrons and they have repulsion. This means that the attractive force of the nucleus is diminished. Attractive force of nucleus and the electrons diminished by increasing shell. The valence electrons are therefore do not feel as much of a pull from the nucleus as they should. Means this attraction gradually decreases. This will affect various trends across the periodic table. This is more of vertical than horizontal trend. Horizontally, that is in period, there is no change in shielding effect, but down the group it increases. It increases because the shells are increases. The shielding effect increases. You can see this picture. This is outer electron and inner shell. Inner shell and outer shell have repulsion. This red arrows have repulsion, but there is attraction with blue arrow toward the nucleus. Right? Again, the definition: electron shielding describes the ability of an atom's inner electron to shield its positively charged nucleus from its valence electron. Valence electron covers, hide, or protect the inner shell. When moving to the right of a periodic table, the number of electrons increases. The number of electrons along the period gradually increases, but the shells remain same, so there is fixed shielding effect. You can see trend of shielding effect along the period as the number of electrons in z orbital, that is z atomic number, increases. but the shells remain same. But down the group, shells increases, so shielding effect increases. But along the period, shells remain same, but as the number of electrons are added, so it the size gradually decreases and the shielding effect remains fixed. Shielding effect is same, but the Z increases. Z means atomic number increases. Atomic number means number of electrons are increased.